Okay, so let's discuss May-June 2024 Pure Mathematics 3 paper 3 in this video. Okay, let's have a look for question number 1. They want us to solve this equation and then give the answer correct to three decimal places. Yeah, okay. So please take note on the request of the question. All right, so when we are having all the equation with indices, what I prefer to do is I will try to group everything with the power x at one side, then everything without the power x, which is only the number on the other side. Okay, so I usually will rephrase my answer in this pattern first, my step in this pattern first. After that, only I take ln both sides to get the value of x. But of course, this is just a suggestion. This is just a suggestion. You can have many other different ways. All right, so this is just a suggestion for you that like you can make it as a reference. If let's say you are lost, don't know how to rephrase them, or maybe you start halfway. So this is one of the technique that you can consider, right? Okay, so let's have a look for the question here. So first step is I want to separate all my indices first, all my power. Okay, if I rephrase it, I will be having 8 power 3, okay, then multiply with 8 power negative 6x. So when I'm having 8 power negative 6x, it is actually the power with negative, right? I can bring it down, become the denominator. So I'm having 8 power 3 minus means divide lah. So 8 power 6x equals to 4 is a constant, I just copy it. Then for the 5 power negative, 5 power negative also I will want to make it become the denominator, which is 5 power 2x. So when you make it become denominator, the negative disappear. Alright, so again, just to remind again, so my final answer, I want to rephrase it into this pattern before I can get my final answer. So I will want to group all the x at one side. So I'm having 8 power 6x divided by 5 power 2x equals to 8 power 3 divided by 4. Okay, then next one. If I try to simplify 8 power 3 divided by 4, I will be having 128 here. Okay, then for this part, right, you can see that I'm having power x at both sides here. What can I do now is I'm using the property or maybe the indices rule where I want to apply this. If let's say I'm having a over b power x, then I can I can put the power into both value a and b. So now I'm going to do it the other way around. Okay, and then another rules that I'm using here is when I'm having a power x power y, I can multiply the power together. So again, for this step also I want to make it the other way around. So if I look at this fraction, right, both of these two number 8 and 5 is having the power x. So what I want to do now is I want to pull out the power x, then left only 8 power 6. Then I also pull out the power x, then I'm having 5 squared. Okay, I'm applying two rules at the same time for this particular step here. Right, so if I try to use calculator and help me, 8 power 6 divided by 5 squared, I get a long value, which is 10485.76, then power x. Okay, so to get the value for power x, the value of x, I need to take ln both sides so that I can pull the x in front. And the x now become a number, right? Okay, so from here, you can see very clearly that this particular step gives you the idea where it is a power x equals to b. So I take ln both sides after this step, then to get the value of x. So the value of x is a super long value from the calculator. So I want to correct it to 3 decimal place. So 3 decimal places, answer should be 0.524. Alright, so this is how we solve this question number 1. Alright, so question number 2. Find the exact coordinates. Please highlight the keyword exact. Your final answer cannot be in decimal number, but it must be in surd form, pi form, or maybe the exponential form. Okay, so the coordinate of the stationary point of this curve and for the x between this value. Okay, right. So when we are talking about stationary point, we need to know that it is basically, we need to find the dy dx, and we let dy dx equals to 0. Then when we let dy dx equals to 0, then from there we get a value for the x, then continue, we can find the value for the y, right? Okay, so let's start with the differentiation first. I'm having the y, which is this equation. Alright, so if you observe this one, you can see that it is the product of two functions. So the product of two functions, you have to apply a product rule, which means that if you want to differentiate the product of two functions u and v, the process is copy the first bracket, differentiate the second, then after that plus, copy the second bracket, differentiate the first. So this is the idea of differentiation that involves the product rule. Okay, and then if you can't remember this formula, basically it is provided in the formula booklet. You can have a look here. So this is the product rule formula that we have. Okay, all right, so let's start. Okay, so for now I want to copy the first bracket, so I copy e power 2x, differentiate the second. So differentiate the sign, I will be having cos 2x. After that, you have to differentiate the 2x, you get a 2. So you have cos 2x multiplied with 2. So this is, I copy the first bracket, differentiate the second. And now I want to copy the second bracket, differentiate the first. So differentiate e power 2x, I get back the original thing, e power 2x. After that, I need to multiply with differentiation of the bracket. So when you differentiate 2x, you get a 2, right? So you have to multiply the 2 at the back. So this is our differentiation dy dx. And second step, I want to let dy dx equals to 0. And at the same time, I will want to factorize out the terms that appear in both terms here, the first and the second term here. So if you have a look, you can actually factorize out e power negative 2x and also the 2 itself. So I'm having cos 2x, then plus sine 2x, multiply with 2e2x. So when I let it equals to 0, I need to solve two equations here, basically. So the first equation will be cos 2x plus sine 2x equals to 0. And another one will be 2e 2x equals to 0. Okay, so maybe we talk about this part first. If you try to take ln both sides to get the value for x, right, so that you can put the x in front, then we can try to find the value of x. But if I take ln both sides, ln 0 will give you a math error. Therefore, from this part, it is impossible for you to get the solution from here. So there's no solution from this part. Okay, so now we will emphasize on this part. We will focus on this part here. So to solve this equation, I'm having sine 2x equals to negative cos 2x. I can bring the cos over, become sine over cos. So what's the identity for sine over cos? Yeah, so you'll be having tangent here. So you're having tangent 2x equals to negative 1. Okay, right. Then we need to try to figure out in which quadrant my answer belongs to and also how to find the value for x. Okay, so first step, I need to find the basic angle first. Okay, so basic angle will be tangent inverse 1. For basic angle, I will not include the negative sign always. I will always exclude the negative sign so that I make sure the basic angle that I get is always in the first quadrant. Okay, so tangent inverse 1 will give you the answer pi over 4, which is 45 degrees. Okay, all right, and now I want to find the answer for 2x. Okay, so we go back to the question here. The question requested for x is between 0 until pi over 2. And now we are looking for the value of 2x, right? So that means when you're looking for the value of 2x, it should be between 0 until pi. So 0 until pi means that the first two quadrants that we have on our Cartesian form, on our Cartesian plane, okay? So first two quadrants, yeah, for 2x. Okay, so let's have a look here. If let's say I'm looking for the answer for first two quadrants in my Cartesian plane, first quadrant is this one where everything is positive. And to get the answer from this part, the answer should be basic angle. The theta here is basic angle. Okay. And for second quadrant, sine is positive. To get the answer from this part, I have to take 180 minus the basic angle. So I need to consider these two quadrants only for my solution here. Okay, so to get the value of 2x, I will focus on the quadrant which give me tangent with a negative value. So tangent negative. In first quadrant, is it tangent negative? No, right? So I don't want the answer from this part. Then if I have a look for second quadrant, is it tangent negative? So yes, because only sine is positive in this quadrant. So to get the answer for this quadrant, you take pi minus the basic angle. So what's the basic angle? In this question, it is pi over 4. So I'm taking pi minus pi over 4. Do I need to continue further for other quadrant? Basically, no need, because in the question, you can see clearly that the 2x is only located between 0 until pi. Okay, so let's simplify our answer here. So pi minus pi over 4, you get 3 pi over 4. And hence, you're having 3 pi over 8 after you divide the 2 to get x. So this is the x coordinate for your stationary point. Let's find out the y coordinate for the stationary point. So to find the y coordinate, you have to substitute your value of x into the y equation here just now. Okay, so let's continue. Y equals to e power 2x. So e 3 pi over 8 multiply with sine 2x. So you're having 2, then 3 pi over 8. When you try to simplify it, you'll be having e power 3 pi over 4. You simplify the power, and then sine, you'll be having 3 pi over 4. So please press calculator to help it a little bit. Okay, so sine 3 pi over 4 will give you the value sec 2 over 2. Okay, or 1 over sec 2. Then for those who are using MS calculator, right, you're not able to get this answer, then what you need to do is like you have to consider the triangle, the right angle triangle. And because 3 pi over 4, the basic angle is pi over 4. So you have to refer to the angle pi over 4. So tangent pi over 4 is 1 sec 2. Then if you have a look for sine 3 pi over 4, which is sine pi over 4, and then both of them, this is in second quadrant, so it should be positive. Therefore, the answer should be 1 over sec 2. So this basic, you need to go through a little bit about the AS topic. All right, how to find all these small angle here. Okay, then if I have 1 over square root 2, if I rationalize it, then I will get sec 2 over 2. Alright, so this is basically my y coordinate. So if I rephrase it again, I prefer to put the number in front. So this is my y coordinate. Alright, then I rewrite my answer again in the stationary, in the coordinate geometry form. So stationary point. I cannot change my answer into the decimal number, yeah, because the question requested for exact value, right? Exact coordinate. So it must be in surd form, pi form, exponential form, and so on. So I'm having 3 pi over 8, which is my x coordinate. Then the y coordinate will be surd 2 over 2, then e power 3 pi over 4. Okay, so this is how we get the answer for question number 3. Question number 3, the square root of this complex number can be expressed in the Cartesian form of x plus iy, where the x and y are real and exact. So by first forming a quadratic equation in x or y, find the square root of this in exact Cartesian form. So okay, please highlight the keyword exact Cartesian form again. So exact also tells you that your final answer must be in surd form, pi form, or exponential form. Okay, so to find the square root of any complex number, right, the answer is still a complex number. So the answer is still complex number, means your final answer should look something like x plus yi. Okay, so usually how we find out the square root of complex number, we are doing it in this way. So we directly take square root of 24 minus 7i, and I let it equals to x plus yi, because I know that my final answer is a complex number as well. Okay, then try to get rid of the square root. I bring the square root over become the square. So I need to square the x plus yi. So expand the expression on the right hand side. Okay, so I'm having negative y square here. It is because of when you square the yi, you are having y square I square, and the I square is basically negative 1. Therefore, when you are having I square equals negative 1, multiply into the I square equals negative 1, multiply into the positive y square, it becomes negative y square. Okay, so I rephrase my answer, my expression here again, so that I can group all the real part with the real part, imaginary part with the imaginary part. And now, to get the value for x and y, what am I going to do now is I want to compare real part with real part. So this part we call it as real because there's no I. Okay, so you compare them together. I'm having x squared minus y squared equals to 24. And I will make this as a first equation. Okay, then how about the second equation? So to get the x and y, I need second equation. I will compare the imaginary part. 2xy, I compare it with negative 7. So from here, I get 2xy equals to negative 7. Then y equals to negative 7 over 2x. So this is my second equation. I'm having two unknown, x and y, and I want to find out the value for them. I just need two equations. So successfully get two equations here already. I will try to solve them simultaneously. Okay, so I will substitute 2 into 1. Okay, so expand everything slowly and carefully. Okay, I want to get rid of the 4x squared at the denominator. I multiply the whole equation with 4x squared. So x squared multiplied with 4x squared, I'm having 4x power 4 minus 49. Then 24 multiplied with 4x squared. 24 multiplied with 4x squared, you'll be having 96. 96x squared. Alright, so you successfully form a quadratic equation in terms of x, right? If I rewrite again, you can observe that basically this is a quadratic form equation. So for quadratic form equation, you can try to factorize them. For those who are not able to see that this is a quadratic form equation, you can let maybe theta or maybe something else. You can let maybe h equals to x squared. So from there, you can see that it is 4h x squared minus 96h minus 49, which is a quadratic equation. If let's say you can't observe and you can't see that this is a quadratic form equation, okay, you can apply this method. Okay, so for me, I can see very clearly, so I can directly factorize them. So to factorize them, right, you can use calculator to help a little bit if you want. So I will get this one, 2x squared and 2x squared, so that I have 4x power 4. For the 49 here, I want to put it in this part. 49 times 2, I get something like 88, is it? Or 98. So 49 and then 1. So I want to have negative, so I put this as negative, this as positive. So if you try to expand it, you get back the quadratic equation. Of course, this particular step, you can try to use calculator to help you a little bit to write it out correctly. Okay, then let's continue here. I want to solve the equation. Okay, so to solve the equation, I'm having x squared equals to 49 over 2. Another part will be x squared equals to negative 1 over 2. Okay, so for this part, I will directly ignore it because if I continue to solve this part, right, the final answer that I get will be overlapping with the answer that I used for this value. So it is not needed for us to repeat the step and get the same set of answer. Alright, so I will directly ignore this part. So we'll continue with this set of formula. So for this set of formula, x squared is equals to this value. Therefore, your x is equals to 7 over 2. Plus minus. Okay, but of course, I prefer to rationalize it. So if I rationalize this fraction, I'm having 7 2 over 2. This is my value of x. And now I want to find out the value of y. So to find the value of y, when x equals to positive 7 2 over 2, what happened to the y? Okay, so there are a lot of students, right? When they successfully found the x and they want to find the value of y, they substitute it back into the equation that involve the square. So for me, my suggestion is please substitute into the linear equation so that you no need to consider which is the correct answer again, which is the wrong answer. So linear equation will give you a direct answer. Okay, but for square here, y square, later you have to take square root, you have to include the plus and minus sign, then you have to double check which is the answer that you should accept, where it makes your set become much more longer, right? So I directly substitute it into this linear equation, not to say linear, but the equation with the power 1. Okay, so substitute x here. So what do I have? Negative 7 over 2. So I substitute here. I will be having negative 7 over 2, then multiply with 7 sub 2 over 2. Okay, or maybe this one I substitute it 7 sub 2 easier for me to simplify. Okay, so if I try to simplify this particular part here, 7 and 7 can be cancelled off. The sub 2 you bring it up, right? So you'll be having negative sub 2 over 2. Okay, so this is my value of y lah. And then after that, I substitute x equals to negative. So negative 7 sub 2 over 2. What is the value of y that I get? So again, negative 7 divided by 2, then negative 7 over sub 2. This is before rationalized one. Okay, then again, I simplify, I will have positive sub 2 over 2. Okay, so you successfully get the value for x and y here. Then let's rewrite our answer again. Okay, so you're having two answers, two set of answer x and y. So square root 24 minus 7i can be written as first set of answer 7 sub 2 over 2 minus sub 2 over 2i. Another one is negative 7 sub 2 over 2 then plus sub 2 over 2i. So by right, these two will be the square root of 2x minus 7i. These two answers. Okay, because this positive x pair with this minus negative value for y. So that's why you can see this is the final answer. Okay, so some students, they're lazy to write out so long. If you want to make it in a shorter way, you can rewrite it in this way. Plus minus 7 sub 2 over 2, then minus sub 2 over 2 with the I here. Okay, because if you have a positive, you substitute positive inside, this is the first answer that you get. If you substitute negative inside this bracket, then the second answer is the one that you get. Okay, so this is how you get the answer for this question. You can list out everything, or you can simplify them into this bracket form. Alright, yeah, so this is how we solve question number. Okay, so question number 4, we are given a diagram, and then they are telling us that we have variable x and y satisfy this particular equation. K and C are the constant. The graph of ln y again x is the straight line passing through the point. So as shown in the diagram, find the value for K and C. Answer is correct to two significant figures. Okay, so for this question, you can observe that our original equation is having the power with the x, so it should be a curve originally. But after they sketch the diagram by using ln y and also the x, so you get a linear equation. So you're converting a curve become a linear equation. The possible way is by taking ln or log both sides, and they are in the form of y equals to mx plus c. Okay, and then just to emphasize here, the values that they give you here, right, like this one in the coordinate form, the 2.8 is still the x because your x-axis is the x. And then the value for 0.372 is basically the value for ln y because your y-axis is ln y. So you need to take note on this now. Okay, then let's start, yeah. Okay, my equation looks like this. Ky equals to e power cx. To make it into the linear equation, the only way that we can consider is we try to take ln or log both sides. Then of course you can apply the rules here, right? So ln e cx, the cx you can put in front, become a constant, a number. So cx multiplied with ln e. And then what's the value for ln e? Okay, so ln e basically is equals to 1, right? Then what else can I do? For ln ky, I'm going to use the property of the ln, where we learned earlier, ln a multiplied with b, I can make it become ln a plus ln b. And I want to apply it in this part on the left-hand side. Okay, so I get ln k plus ln y equals to cx. Then ln y is the y-axis equals to cx minus ln k. Okay, so if you try to compare it now, basically you can see that the ln y is the y-axis. the capital letter Y here means y-axis. So my y-axis equals to ln y. Then m is equals to c. Then x plus a constant term. So you can have a look for the equation after I take the ln both sides. When I rephrase it, it is exactly in the y equals to mx plus c pattern. That's the reason why when you sketch the diagram, it is a linear line. Okay. Right, so my aim now is to find out the value for K and also the C, right? Okay, so I will use the information given in the question. So at the point of 2.8 and also 0.372, how will my equation look like? So my equation look like this. So 0.372 is the ln y. Directly is the whole thing is the ln y equals to 2.8 is the x and then c minus ln k. If I rephrase it, I will be having ln k equals to 2.8c minus 0.372. And I will make it as first equation. Okay, because one equation here not enough for me to get the value for k and c. Therefore, I need the second equation. So to get the second equation, I use the second point given in the question. So at this particular point again, substitute into my equation here, I will be having 2.21 equals to x is 5.1 multiplied with the c minus ln k. Hence, I can get the second equation from this part. Alright, so this is my second equation. Then I have two equations here. You can solve it simultaneously. So equation number 1 equals to equation number 2. Okay, try to group all the c one side. I'll be having 2.3c equals to 1.383. And to get the value of c, I get a very long number. Okay, then my final answer for the c, I have to follow the question. They requested for two significant figures. So the answer for C should be 0.8. 0.80, two significant figure, am I right? Okay, but I need to keep the long value of C so that I can substitute this whole thing into my equation to get the K. Alright, so after that I will get the value for K, so ln K. You can substitute back to any equation equals to maybe 2.8C. Minus 0.372. Okay, then your K, I want to bring the ln over to the other side. Okay, so what's the concept that we use here? Basically, it's like this. When you're having ln A equals to x, if you want to bring the ln over, it is the base e. So you will have A e power x. Okay, so same thing happened here. I'm having ln k. If I want to bring the ln over, it will become e power the number on the right. So the number on the right is a very long value as well. I just try to write out. If you cut it, you can cut it short if you want to express it in your solution. But when you press calculator, just make sure that you press the long value. 65217. Okay, then of course you have to put your k into two significant figure answer as well. So what's your value of k here? So your k is equals to 6.5, correct, to two significant figure. Okay, so this is how we solve this question. Okay, so we are now at question number 5. They want us to express this rational function into partial fraction. Okay, so before we can start doing it, let us try to investigate and see what kind of rational function is this? Is it a proper fraction or improper fraction? Okay, so we can see that the highest power on the numerator is degree 2, is 2, right? So it will be degree 2. And then if you try to expand the bracket at the bottom, you're having the highest power, which is 2x squared. It is also a degree 2. So when you're having the same degree for numerator and denominator, basically this is what we call it as improper fraction. Okay, so for improper fraction, before you do any partial fraction, you have to make it become proper fraction first. Then only you can continue to find out the partial fractions, right? Okay, so this is something that you must check before you separate it into partial fraction. Okay, so once I know that it is improper fraction, the very first step I need to apply is I have to apply long division first, because I want to make my improper fraction become proper fraction first. Alright, so we are having the polynomial. The numerator on top, we make it as polynomial. Okay, then the denominator at the bottom, we call it as a divisor. Okay, right, so divisor, for a long division, you have to expand it. So when you try to expand it, you will get 2x squared minus x and also minus 1. Please expand all this, yeah? Oh, expand all this bracket to get 2x squared minus x minus 1. Okay, then after that, you can start with the long division. So try to think something multiply with 2x squared to get 6x squared. So the something here should be a 3. So that 3 multiply with 2x squared, you have 6x squared. And then 3 multiply with negative x, you have negative 3x. And also 3 multiply with negative 1, you get negative 3. Alright, then after that, you take the terms on top minus the term at the bottom. So you're having this as a 1x. And then 2 minus negative 3, you get a 5. Okay, so what we have here is we call it as quotient. And what we have here we call it as remainder. So we cannot continue the long division anymore. So this remaining part here we'll call it as remainder. Right, so just to recall a little bit. Originally, when we are writing out the polynomial, right, in the equation, in a type of equation, basically polynomial is equals to quotient multiply with divisor. So divisor multiply with quotient plus remainder. Okay, and you can see that in the rational function here, we are having px divided by dx. So that means for the whole equation here, I divide it by the divisor. So px divided by the divisor equals to quotient plus remainder over divisor. So which means that if I want to rewrite this this rational function again, this fraction again, I can write into this pattern where your px now, where your function now is this one, 6x squared minus x minus 2x plus 2 divided by this. Okay, so equals to quotient. So quotient is 3. Remainder is x plus 5. Divisor is x minus 1 and also 2x plus 1. Okay, so this is another fraction that I get after I apply the long division. And you can see that basically for this one, the degree on numerator is 1. The degree at the denominator is 2. So you're having a proper fraction now. So to find the partial fraction, you can start by using this proper fraction. Right, so we continue further. For this particular proper fraction, x plus 5 divided by x minus 1 and also 2x plus 1, you can separate them. These two are linear factors. So this is a pattern that you have. Okay, multiply the whole equation with the original denominator, then your equation will become something like this. X minus 1 and x minus 1 can be cancelled off. So you're having a multiplied with 2x plus 1. Then for the b, you are having x minus 1. Okay, so next, I will let x equals to 1. So that I can get rid of the 2 here. Because substitute 1 in this bracket, so it becomes 0, so b will disappear. Then that's why we can find the value for a. Okay, so for x equals to 1, substitute you are having 6. Then equals to 3a. And therefore your a is equals to 2. Then next one, if I want to find the b, I need to observe this bracket, 2x plus 1. Make the 2x plus 1 become 0, so your x must be negative half. Okay, substitute negative half into the equation here, then you are having 9 over 2 on the left, negative 3 over 2 b on the right. So substitute negative half into this bracket, you'll get a 0. So the a disappear. Therefore, I left only the b on the right. So you can see that from here, b is equals to negative 3. Okay, so you successfully find out the value for a and b. That means you successfully found the partial fraction for this fraction. And please substitute it back into this particular step. Alright, so in short, your rational function will look something like this after I separate it become partial fraction. So I'm having x minus 1, 2x plus 1, 3. Okay, so a complete form of the partial fraction for this particular fraction is this whole thing. Alright, yeah, so this is how we solve question number 5. Okay, so question number 6. They want us to draw the two complex number z, yeah, okay, on an Argand diagram to shape the region that fulfill the two inequality here. Okay, so before you can start drawing, let us modify become the pattern that we want first. I want to have modulus z minus a complex number smaller equals to 2. So it will be 4 plus 3i. So the 4 plus 3i here will be a center for the circle, the center of a circle with a radius 2. Then after that, for the argument part, we are having argument, then z minus a complex number, then greater equals to pi over 3. So if I take out the negative already, so inside the bracket it should be 2 plus I. Okay, so later we have to draw this line. Okay, then now let us decide the scale. So for the circle here, I need to have 4, 3 as a center, then 2 is the radius. So maybe we need the x-axis to be under at least 6. Okay, right, so I'm having 1, 2, 3, 4, 5, 6. Same thing happen for the y-axis. Okay, alright, so now let's start drawing. For the first inequality here, this is a circle at the center for 3. So center for 3 is this part. Radius is a 2. So to plot the radius 2, I will maybe put a small point here, 2 unit away, and also 2 unit above and below. It will be something like this. Okay, so I try to make it as a circle. Okay, so for this inequality, because they are saying that smaller equals to 2, so smaller equals to 2 means that we are considering the whole area below, the whole area inside the circle. So by right, I have to shape the whole area inside the circle. But I have to consider another inequality here, therefore I will shape it later. But for this particular inequality, it is inside the whole circle, yeah? Right, then for argument z minus 2 plus I, what we need to do is like, we have to plot a point at 2, 1. So this is a point that we refer. So on the right hand side of 2, 1, maybe I try to make a horizontal line so that I can measure the argument from this horizontal line here. Okay, so to measure the argument, they are looking for pi over 3. So pi over 3 means 60 degree, right? Okay, alright, so by right now, your graph should measure from this part and going up for pi over 3. So we need to decide how is our direction of the line. Is it like this one, is it like this, or is it like that? So all these are the angle less than 90 degree, right? So some students can measure by using the protractor if you want. If let's say you didn't bring in the equipment, okay, or the tools to measure the angle, then basically you can roughly sketch it by imagine the triangle. Use the help of triangle. So let's say this is the horizontal line. This is a horizontal line. Okay, alright, this is 90 degree and this is pi over 3. So we did learn about the triangle, right? When we are having pi over 6 here, opposite will be the 1. Then this is 2 and this is 3. So that means if you want to draw this particular line here, you can refer to this one. Use a triangle as a reference. So the base must be 1. So that means from the start of the point to here, 1. Okay? And what's the height? So the height is cert 3. So cert 3, if you observe the value, cert 3 should be, if I'm not mistaken, should be 1.7 something, right? Cert 3. Yeah, it should be 1.732. So this is 1.732. That means when you want to sketch the top one, the vertical height is 1.32. So this is 1 unit, and then you go up for 1.7 unit roughly. So maybe roughly 1.7 units is here, is this one. Okay, so this is a point that you need to draw where it should look something like this. Okay, where this angle here will be pi over 3. Okay, so maybe I label it somewhere here. So this is actually pi over 3. Okay, so how I decide the point? I'm looking at the point by using the triangle to help me a little bit. Right, unless you have the tools to measure the angle, then it will be much more easier. Okay, then after that, so you can see there's an invisible triangle here, where the bottom part is 1 unit and the vertical line is the cert 3 or 1.7 something. Okay, right. And now they want us to sketch the area where the angle is more than pi over 3. So where's the angle for more than pi over 3? So again, I enlarge it one more time. Okay, so for this part of the graph, right, you can try to imagine that you're having 4 parts here. This is something like the x and y axis. Okay, for all the area at the bottom, right, if you measure the angle from this horizontal line until this part, all these are negative angle. So all these negative angle means smaller than pi over 3. Smaller than pi over 3. So from this one, 0 until pi over 3, also still smaller than pi over 3. Okay, so how about this area? From the line until the negative horizontal axis. So for this one, it is from pi over 3 until pi, if you want to calculate the argument. So this area considered as greater than pi over 3. Okay, so the area is having the angle greater than pi over 3. So that means if you want to shade the area, it should be the whole area on the left-hand side of the line. Okay, so this is how we decide it. So hopefully you have the idea how to shade the correct area. Okay, so now let me erase everything first. Okay, so I know that I have to shade the area on this part of the line. This part of the line, and just now consider back the first circle. Circle, I need to shade everything inside the circle. So the overlapping part for these two inequality will be this one. Okay, all right. Yeah, so your overall graph will look something like this. Okay, so this is what we have for first part, question 6, part A. Let's continue to part B. Okay, so for part B, they want you to calculate the greatest value of argument z for the points in this region. Okay, argument z. So argument z means that you have to measure the angle from the point 0, 0, because it is z minus 0 plus 0i. So to measure the argument, you need to make 0, 0 as a reference point. So let's have a look here. This is 0, 0. So I make this as a reference point. And then on the right hand side of 0, 0, I start measure the angle. So they are asking for the greatest argument, which is the greatest angle, right? You can use a ruler, place on 0, 0, and also move upward and downwards, okay? Move sideways, okay, from the shaded area. And then your 0, 0 is fixed. Your ruler is fixed at 0, 0. You just move the ruler up and down, okay? And please observe which is the last point of your ruler that touch the shaded region. So I believe that your ruler might touch the last point of the shaded region is somewhere here, but I will not know what is the coordinate. Okay, but I just know that if the area, okay, the last point that your ruler touch the shaded area will be roughly this part. Okay, so from here, you know that this is the last point, okay, that your straight line touch. Sorry, I need to draw a line here. Okay, which is somehow a tangent, okay, of the circle at this particular point. Okay, and then this is the greatest argument that I want to find. Alright, so this arrow here, this is the greatest argument that I want to find. Okay, so since I don't know what is the position or what is the coordinate for this particular black color point here, but I have to use some common sense or some small knowledge that we learned earlier. Okay, so to help us to get the answer. Alright, so to get this greatest angle, what I need to do is like, I use this property here. Maybe I try to observe there's a triangle here. I know that this is a 90 degree because this particular line, if your graph is nice enough, this particular line should be the tangent to the circle. So from the point itself to the center, it should be a 90 degree. Okay? And after that, if you try to join one line here to the center, this will be the hypotenuse. Okay, I can't draw it properly. Let me try again. Yes. Let's say this is the center. Okay, so this is the hypotenuse. Alright? For this particular length, it is a 2 unit because you can observe that it is actually the radius of the circle. How about the length? How about the length for the hypotenuse? For the length of hypotenuse, what is it? It is actually the distance between 0, 0 and also between the point 43. 0, 0 to 43. It is the distance 0, 0 to 43 because this is the length and it is also the hypotenuse in triangle. Okay, so I know this the length for these two sides. And now my aim is to find the black color angle. How can I find the black color angle? Okay, I use the green color one. This is the green color angle. So this green color angle is basically the argument for the complex number 4 plus 3i. Because the hypotenuse is the line for 4 plus 3i, right? So this argument itself, this angle itself will be the argument of 4 plus 3i. Then I want to add the blue color. So I take green color plus blue color angle to get the black color one because the black color is the greatest z that I have. Okay, so how to get the blue color? So to the blue color, I'm going to use the ratio of the triangle for this right angle triangle. Okay, to get the answer because I already have two sides. I have the opposite length and also the hypotenuse length. Therefore, it is not hard for us to find out the blue color angle here. So you can see that the black color one is green color plus blue color. So that's how we get the greatest value of the argument z. Okay, so you roughly know how to figure it out already. So let's continue with the steps. Okay, so to calculate the greatest argument z, so maybe I write greatest argument. Okay, so from greatest argument z, I know that I have to use the argument of the point 4 plus 3i, 4 and 3i, and then add, like what I told you just now, right, the angle in the triangle. Okay, so I use green color again. Argument 4 plus 3i. Okay, then plus the blue color angle in the triangle. Okay, so how to get the argument for 4 plus 3i? So argument for 4 plus 3i means that it is the argument for the complex number 4 plus 3i. So it is in the first quadrant, therefore the argument will be tangent inverse 3 over 4. Okay, then plus. How about for the triangle? So for the triangle here, you know that sine for the angle is equals to opposite over hypotenuse. So opposite is a 2. Hypotenuse is the length for the line 0, 0 to 4, 3. So it will be 4 square plus 3 square, which is equals to 5. Okay, therefore, to get the angle in the triangle, it is actually sine inverse 2 over 5. Alright, so I put it in my calculation step here. It will be sine inverse, then 2 over 5. Alright, yeah, so after this step, you just try to use calculator to help it a little bit. So you eventually will get the answer either in degree, which is 60.4, or your radian answer will be 1.06. Direct to 3 significant figure for the radian, and then the 1 decimal place answer for the angle in degree. Okay, so of course, some students might have some other technique to find the greatest argument, but this is just one of the suggestions that I can show you here. Alright, okay, so this is how we solve question number 6. Okay, so question number 7, we are given a function, and then they want us to show that x plus 7 is a factor of fx. So to prove that it is a factor of fx, I need to substitute the value of x equals to negative 7 into the function. If it is equal to 0, that means there's no remainder, so it will be a factor. If let's say the value is not a 0, that means you have a remainder, therefore it will not be a factor. Okay, so directly substitute the negative 7 into my equation here, into my function. Okay, so use the calculator to help you a little bit. You will be having all this value here. So I've expanded term by term, yeah. So this is what I get. Then again, simplify by using calculator, you'll get a 0. So like what we know earlier, right? If let's say substitute the value inside and you get a 0, that means this particular x plus 7 will be a factor of fx. So make a small conclusion on this part. Okay, so you can write that x plus 7 is a factor of fx. Stop. Okay, then let's continue to next part, part B. For part B, they want us to find the quotient when it is divided by x plus 7. So just like what we have here just now, right? We already know that it is a factor. So to find the quotient, you can use comparison method or you can use the long division method. So for me, I prefer to use a long division, easier for me lah. Okay, so for long division, what do I have here is 8x power 3, then plus 54x squared, minus 7x, minus 21. And the divisor is x plus 7. Okay, so you ask yourself, something multiply with x to get 8x power 3. So the something here should be 8x squared. Something multiply with 7, so 8x squared multiply with 7, you have 56x squared. Then you draw a line. Then you take the term on top minus the term at the bottom, so you're having negative 2x squared for this part, and then negative 17x. So next one. For the quotient, something multiply with x to get negative 2x squared. So what's the something here? So the something here should be 2x. 2x negative multiply with x, you have negative 2x squared. Negative 2x multiply with 7, you are having negative 14x. Then continue further, you are having negative 3x minus 21. So now, what is this term now? Something multiply with x to get negative 3x. So the something here will be negative 3. So negative 3 multiply with x, you have negative 3x. Negative 3 multiply with 7, you have negative 21. So by right, at the end of your long division, right, there should be no remainder here. So which is correct, because x plus 7 is a factor. This is what we have already proved just now. Okay, so there's no remainder here. This is something for sure. Okay, so now what is the quotient? So for information, you need to know that the thing on top here will be our quotient. Alright, so they're asking for quotient, so I rewrite my answer again. Okay, so this is the quotient that I have. Alright, so let's have a look for part C. For part C, they want us to solve the equation 8 cos power 3 plus 54 cos square, then minus 17 cos, and also minus 21, then equals to 0. And your theta is between 0 until 360. Okay, so for this question, if you try to observe, right, this question is very similar to what we have in the function just now. So our function just now is 8x power 3, then 54x squared, minus 17x, and then minus 21. So this is my function fx just now. So basically to solve this equation, right, you have to use the concept or maybe the answer that we found out just now in part A and part B and try to factorize it. So you can see the pattern are the same. Okay, it is basically the same polynomial lah, just that the x has been replaced by cos theta. Okay. Alright, so later when you want to simplify anything or not, you also need to replace the x by cos theta. Okay, so let us go back to part B again. So for part B, if you try to recall back again the concept that we learned earlier, we'll be having actually polynomial equals to divisor multiply with quotient plus remainder. Okay, so for this particular question that we have, your polynomial is this whole thing. Okay, can be written as divisor multiply with quotient. So x plus 7 multiply with this one, quotient. And there's no remainder, right? So the remainder is 0. So this polynomial can be written as this whole part here. So I want to do it in my part C. Okay, so I take factor multiply with the quotient that I get. Okay, so continue from here. By right, I will be having x plus 7. Okay, then I'm having 8x squared minus 2x, then minus 3, and equals to 0. But now, because I'm trying to solve this question, right, this equation, I will replace my x by using cos theta. So I'm having cos theta plus 7, then 8 cos square theta minus 2 cos theta minus 3. Okay, then before we can solve it, let us investigate more. This larger bracket here, the quadratic form bracket, I can still continue to factorize it. So I will be having 4 cos theta and also 2 cos theta for this part. Then I should have 3 and 1 here. 3 times 2 is a 6. So I have negative 6 plus 4. Okay, so you successfully factorize it into the small bracket. So now let us continue to solve them. Cos theta equals to negative 7 for the first one. Then cos theta equals to 3 over 4 for the second equation. And after that, cos theta equals to negative 1 over 2 for the third equation. For the first equation here, if you try to take cos inverse negative 7, there's a math error. So no solution for this part. Because it is a math error, you cannot continue anymore. Right, so maybe you can start from the easier one. For cos theta equals to negative half. Okay, so cos theta equals to negative half. Basic angle is 60 degree. If you press cos inverse, okay, maybe I write it like this. This is the basic angle, BA. So basic angle will be cos inverse half. Ignore the negative sign. Okay, so if you take cos inverse half, you'll be having 60 degree. Then now you have to consider in which quadrant you are having the cos negative, because they are looking for cos negative, right? So in which angle, in which quadrant do you have cos negative? So one more time, we need to refer back to this one. Okay, so I'm having everything positive, sine positive, tangent positive, then cos positive. Okay, so the first quadrant answer will be the basic angle itself. The data in this diagram here means basic angle, yeah? So in first quadrant, everything positive. To get the answer from first quadrant, the answer is basic angle. In the second quadrant, 180 minus basic angle. Third quadrant is 180 plus basic angle, and this one is 360 minus basic angle. Okay, so my basic angle here is 60. Looking for cos negative. So first quadrant, I don't want the answer. Second quadrant, I want the answer, so I take 180 minus 60. So 180 minus 60 means 120. Then third quadrant also cos is negative. So I want the answer from this part. 180 plus 60, you have 240. Then the fourth quadrant answer I don't consider, okay, because it is cos positive. I'm looking for cos negative. Okay, same thing happened for the second equation here. So to find out the basic angle, I have to take cos inverse 3 over 4. So by right, this answer, the basic angle is 41.4. Okay, then again, I want to get the value for theta. Looking for the quadrant with cos positive. Okay, cos and positive here. Okay, in first quadrant, cos is positive, so I want the answer from here. The answer is basic angle itself. Second quadrant, cos is negative, I don't want the answer. Third quadrant, cos is negative. I also don't want to answer. Fourth quadrant, cos is positive again. So I want to answer from this part. To get the answer from this part, you take 360 minus the basic angle. So by right, you're having 318.6. Okay, so we'll stop here because for the data, it is stated that it is from 0 until 360. That means I have go through one round for all these two equations. Okay, then I just compile all my final answer again. So my data, there are four answers for the data here. The first one is 41.4, then 120, 240, and also 318.6. So don't forget that in our standard requirement for the angle in degree, right? You have to make sure that your answer is in one decimal place. Alright, so this is how we solve question number 7. Okay, so question number 8, express this particular thing in this form. R is positive and also alpha is from 0 until pi over 2. They want to have the exact value of R and alpha. Okay, so exact value, we highlight the keyword exact value. So this is basically what we have now. We are having A cos theta, then plus B sine theta. To find the R formula will be equals to A squared plus B squared. Okay, then the alpha formula will be actually tangent inverse. Okay, so B over A. So I think this question is quite straightforward. Right, so let's start. To find the R, it is A squared plus B squared square root, right? So it will be 3 squared plus plus square root 3 squared. So you're having 9 plus 3, which is a 12. So square root 12, you can further simplify to become 2 sub 3. Okay, then how about the alpha? So to get the alpha, the formula is tangent inverse B over A. So sub 3 over 3. The alpha must be in radian form because in the unit here given is in radian. So tangent inverse sub 3 over 3. By right, you'll be having, it is 1 over sub 3. Okay, so 1 over sub 3 should be 30 degrees, sorry. So 30 degrees will be actually pi over 6. Alright, then just rewrite your answer one more time. So 3 cos 2x minus sub 3 sine 2x can be written as 2 sub 3 and then cos 2x plus alpha. So the alpha will be pi over 6. So this is how we express it in this particular pattern that they want. Alright, then after that, let's have a look for part B. Okay, so for part B, they want us to find the exact value, highlight the keyword exact value again for this particular term. Okay, then simplify your answer. Right, so you can see the word hence. So very likely, right, you actually have to apply the result that we find out in the first part into this integration before you can continue. Okay, so let's start. We are having pi over 12 and then 0 with the term like this. Okay, so for the very first step, I want to substitute answer in first part into this part now. Because you can see that this particular expression at the bottom, right, is actually what we try to change the pattern just now, right? So we can replace the answer in the first part in here, in this particular part here. So you'll be having 2 sub 3, then cos x plus pi over 6, sorry, 2x plus pi over 6. So 2x plus pi over 6. Then dx. So what's the next step here? I try to expand. What do I have at the bottom part? Maybe for me, I take out the constant 3 first. Then I will be having 1. Okay, so expand the 2 with a square and also multiply with sub 3 square. I'm having 12. Then I will have cos square. 2x plus pi over 6 after I expand the square. Then I will take out the 12, it is constant, I take out the 12. 1 over cos square, I'm having secant square, right? So I make it become secant square. So why do I change it become secant square? It is because of it's easier for me to integrate later, because I know how to integrate secant square directly. Okay, so simplify the constant outside. Start with the integration. Integrate secant square, you will be having tangent. Differentiate tangent get secant square, right? So integrate secant square, you have tangent. Then divided by, you have to differentiate the thing inside the bracket. Differentiate 2x, you get a 2. So pi over 6 is a constant, differentiate you get a 0. So differentiate 2x, you get a 2, therefore you need to divide it by a 2. Then you'll be having pi over 12 and also 0. Then again, before I substitute in the value, I prefer to take out all the constant first. So I take out the 2, become 1 over 8. Substitute pi over 12 inside my calculation here. Pi over 12 times 2, I get pi over 6. Pi over 6 plus pi over 6, you get pi over 3. Okay, then minus, substitute 0 inside, you'll be having tangent pi over 6. Okay, then substitute the value in and you can simplify and get the answer. Okay, so tangent pi over 3. For tangent pi over 3, you will get sub 3. You must keep your answer in the exact form because they're asking for exact value. Okay, then the tangent pi over 6 will be sub 3 over 3. Okay, so for the students who are using MS calculator, your calculator might not be able to give you the answer like this. Then, of course, you have to recall back to the triangle that we learned earlier. Okay, so always remember the ratio of the important triangle here with the important angle. So pi over 6, opposite is a 1, then the hypotenuse is a 2. So for pi over 3, the opposite will be sub 3. Okay, so from here you can see that for tangent pi over 3, it will be sub 3 over 1. This is how you get the sub 3 over 1. Tangent pi over 6 will be 1 over sub 3 lah. But 1 over sub 3, after you rationalize it, you will be having sub 3 over 3. So you can make something like sub 3 is an apple. So you're having 1 apple minus 1 over 3 apple. So you're having 2 over 3 apple here. Okay, then you further simplify it. You'll be having 1 over 12 sub 3. Alright, so this is how we find out the exact value for this integration. Okay, so we are at question number 9 now. There's a container in the shape of cuboid. It has a square base of the side x. So I think the diagram shows very clearly the height is 10 minus x. It is given that x varies at a time t, where t is greater than 0. The container decrease. Highlight the word decrease. So decrease means that when you want to put anything in the equation whatsoever, so very likely you have to include the negative sign. Decrease in volume at the rate. So volume at the rate give you the idea that they are talking about dv over dt. Okay, so which is inversely proportional. Highlight the keyword inversely proportional. If let's say proportional means directly multiply the variable with the number, but inversely proportional means it is divided. So that means proportional means there's a value k lah. Inversely proportional with t means that you have to divide it by a t. If it is which is proportional to t means kd, but if it is inversely proportional to t, that means k over t. And don't forget about the word decrease just now, so you should be having a negative sign here. So this particular sentence, okay, from this particular sentence, I can form one simple equation in this. Alright, okay, then after that, they are saying that, okay, when t equals to half, x equals to half, t equals to 1 over 10, x equals to half, and all these rate of change for x is this one. They want to show that x and t satisfy this differential equation. Okay, so before we can start, right, let's have a look for the answer here. They are asking for dx over dt, but for the equation I formed just now is dv over dt. So to get dx over dt, very likely I need to apply chain rule. Okay, so to apply chain rule, I need to find out the relationship between the volume and also the x first. Alright, so this is the setting of the question. So let us start, yeah. Maybe I copy down this one in my solution first. So from question just now, I get this equation. How can I try to link the volume with the variable x? So the volume with the variable x, I can get it from the cuboid. Okay, so I know that volume should be the area of base multiplied with the height. So the area of base is x squared. Multiply of height is 10 minus x. So this is how we relate the v and also the x, the volume and also the length of the sides. Okay, then after that, to get dx dt, I know that I need to apply chain rule. So before that, I try to find out dv over dx first. This is what I get. Okay, so I get some equation in dv dt, another equation in dv dx. So I can start finding out dx dt. So how can I find the dx dt? Basically, so I use the chain rule that we learned earlier, dx over something multiplied with something over dt. So I think very obvious that the something here should be dv, because I have all the equation in terms of v, t, and x. Alright, so what is my dx dv here? So the dx dv here, I need to make this upside down. I'll be having 1 divided by 20x minus 3x squared. Then how about the dv dt? So the dv dt is negative k over t. So when you simplify it, the overall equation looks something like this. I'm having negative k, and then I'm having t at the bottom, then 20x minus 3x squared. Alright, so if you try to observe this equation again, there's no k. So I have to find the value for k so that I can get something like this. There's no k in this equation, right? So how can I find the k? I have to use the initial value given in the question. So there are important values given in the question here. Okay, so the rate of decrease of x, that means it is dx dt. Okay, so the rate of decrease of x is this one. Alright, so let us start, yeah? It is given t equals to 1 over 10, x is half, dx dt is this value. Okay, so I want to substitute into my equation here. So dx dt, I substitute 20 over 37 equals to, here, negative k, I don't know what is it, I just copy negative k. T is 1 over 10, right? So you put in 1 over 10. Then 20x, so you substitute half into the 20. So 20 divided by 2, you're having 10. Minus half, you square become 1 over 4. So you'll be having 3 over 4. Okay, so if you try to simplify all the values here, you'll be having k equals to negative half. Okay, so I think there's an error I made somewhere, right? Oh, sorry. I think this one. The rate of decrease of x, it should be negative because because of the word decrease. So of the word decrease, I think I forget about the negative sign here. This one. Okay, and then if this is negative, so I should put a negative here, and by right my k is positive half. Yeah, so don't forget about the negative sign because they are talking about the rate of decrease. So by right you should put a negative sign in front. Okay, then after that only you can get the correct answer. So you find out, you rewrite the equation again. So dx dt equals to what? Dx dt equals to, copy the negative, k is half, right? So you're having 1 over 2t, and then 20 negative x minus 3x squared. Yeah, so this is basically how we get the differential equation as shown in the question. Right? Okay, then let's continue to part B. For part B, what are they asking for? So they're asking us to solve the differential equation, express t in terms of x. Okay, so to solve the differential equation, first step I need to separate the variable to different sides. So I'm having variable x and also variable t. and my equation looks something like this. Negative 1 divided by 2t, then 20x minus 3x squared. Okay, so I have to separate all the x to one side, all the t to the other side. Okay, so if I want to keep my x on the left, so this bracket with the x, I will bring it to the left. So I'm having 20x minus 3x squared dx. Then I bring the dt over, I still have negative 1 over 2t on the right, multiplied with dt. So from here, you can see very clearly that I have successfully separated the variable to two sides. All the x on the left, all the t on the right. So only I start the integration. Okay, for this part, integration should be no problem. I think it's quite straightforward. This is also not really hard, so we can directly start with it. So differentiate 20x, you will be having power plus 1, which is 20x squared divided by 2. So eventually you're having 10x squared. Integrate this one, 3x squared, power plus 1 become a 3 divided by 3. So eventually you're having x power 3. So this integration is quite direct. Then for this part, I will want to take out the constant half first, so left only 1 over t. Integrate 1 over t, you have ln t. So also very easy integration. So you're having ln t plus c. Don't forget about the constant term at the back. Okay, then now I try to find out the value for c first before I can express it t in terms of x. So to find out the c, I use back the value given just now. It is given that t equals to 10, 1 over 10, and then the x is equals to half. So what do I get it after I substitute the value? So substitute half here for this whole part. So you'll be 10 multiplied with 1 over 4 minus 1 over 8 equals to negative half ln 1 over 10, then plus c. Simplify these two values here. I'll get 19 over, I will get what, I will get 19 over 8. Then plus half ln 1 over 10. Okay, but I doesn't feel that this one is simplified enough lah. So for me, I want to further simplify it. For the half, I just copy, and then for ln 1 over 10, I want to take ln 1 minus ln 10. Okay, because previously we did learn about this, right? There's no correct or wrong, okay? But for me, I prefer to further simplify it. So previously, we have the idea where if you're having ln A over B, I can separate it become ln A minus ln B. Okay, so this is what I'm applying now. And after that, you should know that what's the value for ln 1 here. So ln 1 basically will give you a value of 0. So you can see that your C is actually 19 over 8 minus half ln 10. Okay, so after I get the value of C, only I substitute it back into the equation here. Okay, then only I start rephrasing my answer, become t in terms of x. So C is 19 over 8 minus 1 over 2 ln 10. Okay, yeah, so first step, I will want to group all the term with ln together. I put it on the right, so I'm having positive ln t plus half ln 10. 19 over 8, I keep it on the right. All the terms here, I move it to the right as well. So I'm having negative 10x squared plus positive x power 3. Okay, combine these two terms together, I'm having half ln t plus ln 10. Then the right hand side remain the same. Okay, then next step, I want to use the concept of ln A plus ln B equals to ln AB that we learned earlier. Okay, I'm having ln 10t. Then I want to get rid of the 2 here. I bring it over. The 2 at the denominator, I want to bring it over. So when I bring over the whole equation here, I multiply with 2 lah. Whole expression on the right hand side. So it becomes 19 over 4 minus 20x squared, then plus 2x power 3. Okay, so we are one step closer to the final answer. So now I want to get rid of the ln. Ln is base e, right? Okay, so if let's say you're having ln A equals to B, when you want to bring the ln over, it will become base e with the power B. So we are doing it now for this one. So I don't want the ln now, I bring it over, so it will become e lah. 19 over 4, maybe I put it into the decimal number, so it is 4.75 minus 20x squared plus 2x power 3. Then final step, you bring the 10 over, it becomes 1 over 10. E power 4.75 minus 20x squared, then plus 2x power 3. So this is how we get the answer for t in terms of x. Right, yeah, so this is how we solve question number. Okay, so we are at question number 10 now, which is the last question for this paper. Right, so you are given the vector equation for 2 straight lines, and then given that the acute angle, so between the direction of these lines is pi over 4. Find the possible values of A. Okay, so every time when you want to find the angle between 2 lines, right? If let's say in vector form, basically we are having the general equation like this. So I have to use P, vector P dot vector Q, then find out the modulus of P, multiply with modulus of Q, then multiply with cos theta. Okay, right, so first of all, to find out the angle between the 2 lines, right, they already hint you very clearly, acute angle between the direction of these lines. So where are the direction of this line? These are the direction of this line. These are the direction of the line. Okay, so all this direction here, you can label it lah. So maybe I will label it as P. Then maybe I will label this as Q if you want. Okay, so you can assume that this is a P, this is a Q, and therefore you can use this equation and continue to solve it. This is the information I can use to start with because in the question, they already give you the answer for the angle, right? Okay, so what is your P? So if you write out P, I prefer to write out in the column vector form. So P is 3, 4, 8. So 3, 4, and 8. Dot the Q. So what is the Q here? Negative 1, 2, and 2. And they are equals to how to find the modulus. So all these are quite basic, yeah. So please try to find out. So 3 square plus 4 square, then plus a square. Same thing happen for the second direction. So you're having negative 1 square plus 2 square and plus 2 square. Then the value for cos is cos, and then theta, you already know that the angle is pi over 4. Okay, so next step, try to find out the dot product for these two vectors here. So 3 times negative 1, you get negative 3. So 4 times 2, you get an 8, and then you have 2a here. Okay, so for this part, square root, you're having 25 plus a squared. The second square root, you're having square root 9. Then the third one, cos pi over 4, you'll be having 1 over sec 2. Okay, then for me, because I feel that all the square root here are very troublesome, so I square the whole equation. Okay, so I square the whole equation. On the left hand side, you're having 2a plus 5. So I have to square it. After I square this, I'm having 25 plus a squared. Square the square root 9, you are having a 9. Square this one, you are having a half. Okay, then expand the square on the right. Okay, then simplify what I have on this part. So multiply in the 9 lah. So I'm having 225 plus 9a squared. Okay, and after that, further simplify it, get rid of the half. So I'm having 8a squared plus 40a plus 50 equals to 225 plus 9a squared. Then simplify this equation. So by right, you'll be getting this. Then try to factorize it. And after that, you'll get two values for the a, where a is equals to 35 and also a equals to 5. Okay, so if you want it to be safe, right, you can actually double check your dot product because they're asking for acute angle. So your dot product must be a positive value here. So 2a plus 5. Substitute a inside here, 2a plus 5, definitely you get a positive value. Then a is 5, substitute it also you get a positive value. So that's why these two values are valid. So you are having two answers for the a, which is a equals 35 and also a equals to 5. Okay, yeah, so let's continue to part B. Okay, so for part number B, so now they tell us that given instead that the lines are intersect, find the value of A and also the position vector of point of intersection. Okay, so the lines intersect. When the line intersect with each other and we want to find the intersection point, usually we'll equate equation number 1 to equation number 2 and then we solve them. Okay, so same thing happened here. So what is my vector equation for the first line? So the vector equation for first line will be 1 plus 3 lambda and then 1 plus 4 lambda and also 2a plus a lambda. So how I get this first equation here? It is from the question itself just now. Okay, so if you have a look for this one, 1, 1, 2a, right? So if you expand, it will become 1, 1, 2a. Then you have a plus, so plus 3, 4a. So you're having 3 lambda, 4 lambda, and also a lambda. This is how we get the vector equation in the column vector format. It is actually given in the question. Okay, so I equate it with the second equation here, right? So the second equation will be negative 3 minus mu, then negative 1 plus 2 mu, and also 4 plus 2 mu. Alright, so now I will be getting the first equation first to solve and get the mu, yeah? Okay, so 1 plus 3 lambda equals to negative 3 minus mu. So I get the first equation in terms of mu and lambda first. And the second equation, maybe I want to use without the a1 easier, okay? Because with the a1 I cannot solve. Right, so I'm having this as a second equation. Alright, so to get the value for lambda and the mu, I solve them simultaneously. Okay, so if you continue to solve it slowly, by right, your answer should be lambda, right? Lambda equals to negative 1. Okay, so if you get lambda equals to negative 1, substitute it back into the first equation. At the same time also, you'll get your mu equals to negative 1. Okay, and since the line intersect with each other, right? So the equation will be correct if you substitute these two values into the third equation. It will be the same, okay, if you substitute into the third equation. So I'm using this third equation to find out the a. So 2a plus a lambda, lambda is negative 1, equals to 4 plus 2 mu. So mu is also negative 1. So you substitute into the third equation here that we haven't used just now. From here, you will be getting your a equals to 2. So you successfully get the answer a equals to 2 already. Then how can I find the intersection point for the line? To find the intersection point, you can substitute lambda or mu or a. Go back into any of the equation. So for me, I will substitute the mu inside this second equation here, I'll get a point directly lah. If let's say you want to substitute it here, then you have to use two answer, which is lambda -1 and also the a equals to 2. Both, no matter which equation you're using, the final answer will be always the same lah for the intersection point. So to be easier, I will substitute it into this mu equation. Okay, so I'm looking for the position vector, intersection point. Okay, so basically it will be -3 minus mu. Mu is -1, right? Then I. Then plus -1 plus 2 mu. Mu is -1. Then j. Okay? And after that, 4 plus 2 mu. Okay. Then if you try to simplify it, you'll be having -2i, then minus 3j, and also plus 2k. Okay, so this is basically how we get the point of intersection. The vector, the position vector of the intersection point. Alright, so here's the end of the discussion for this paper. Thank you very much for watching the. Okay, so this is the last question for this video, yeah. Okay, not the question number 10. I think I overlooked this question. Okay, so let's have a look for question 11. They want us to use the substitution of 2x equals to tangent theta to find the exact value, highlight the keyword exact value, okay, for this integration. And our answer must be in the form of a plus b pi, where a and b are rational numbers. Right. Okay, so for this question, they already give us a very obvious hint. They want us to use integration by substitution, okay, to carry out the integration here. So we will start with what they give us first. So first step, we are going to find out, 2x equals to tangent theta. Okay, so start from here. I want to find the differentiation for this equation. So when I differentiate this one, differentiate 2x, I get a 2. I want to differentiate with respect to theta, so I'm having dx d theta. Okay, equals to tangent theta. If you differentiate it, you will have secant square theta. And I want to rephrase dx in terms of theta lah. So you're having 1 over 2, then secant square theta, d theta. Okay, so why am I doing so is because of, in my question here, I'm having all the variable with x. So by using substitution, I want to change all the variable here into theta later. So I will want to write out dx in terms of d theta first. Dx into the theta first. Alright. Okay. So after you have this, we also need to change the limit for the integration, where all the limit here are for the value of x. So change the limit when x equals to 0. What happened to your theta? So your theta will be tangent inverse to x, right? Okay, so you move the tangent over, become tangent inverse to x. So 2 multiplied with x, you get a 0. So tangent inverse 0, you get a 0. Okay, then after that, when my x is equals to half, what's the value of theta? Again, substitute into the equation, tangent inverse 2 times x. So 2 times x means 2 times half. You are getting a 1 here. So tangent inverse 1, you'll be having pi over 4, 45 degree. Okay, so after everything is settled, okay, everything is done nicely. So we will try to change all my variable x into theta. So we'll start the question here. I'm having half, 0, then 12 over 1 plus 4x squared, then square, then dx. Okay, so first step, I prefer to take out the constant. Okay, or maybe we don't need to take a constant first. We try to change everything, become theta first. Okay, so I start to change everything, become theta. 0 is the limit, right? Just like, and we find out the theta is still a 0. When x equals to half, okay, and we found that the theta should be equals to pi over 4. So I substitute pi over 4 here. Copy the 12. Okay, so 1 plus 4x squared theta. 4x squared can be written as 2x the whole thing square. Okay, 2x the whole thing square can be written as tangent square. So I'm having 1 plus tangent square theta with a square outside. And then for the dx, you can see that dx can be written as half secant square d theta. So I'll be replacing here with half secant square d theta. Okay, so we slowly simplify our equation first, our expression first, before we can continue to integrate it. 12 divided by 2, you get a 6. So for me personally, I prefer to take out the constant from the integration part. Okay, secant square, I have secant square on top. Okay, then d theta. 1 plus tangent square, I can write it as secant square. So I'm having secant square theta square at the bottom. Okay, so my equation now looks slightly easier or slightly simpler. And then secant square theta on top can simplify with the square at the bottom. Therefore, you are having 1 over secant square. Okay, so what can I write 1 over secant square as? Secant square is 1 over cos. Oh, sorry, secant is 1 over cos. So 1 over secant square, we will get cos square because it is 1 over cos square. So it will become cos square theta. And now we need to continue to integrate cos square theta. All right, so what's the correct technique for us to integrate cos square theta? When you're having a square here, you cannot direct integrate it. So you have to try and change the cos square theta become something without the square. So what can I think about this is we are using the double angle formula for cos because I'm having cos. If let's say I'm having cos 2 theta, okay, it can be written as 2 cos square theta minus 1. Then when I rephrase it, my cos square theta will be equals to cos 2 theta plus 1 divided by 2. So if you try to observe this particular part here, right? If you want to integrate cos 2 theta, you can integrate. If you want to integrate the constant term, also can integrate. Alright, so instead of keeping it as cos square, I can't integrate it. I have to change it become this one, this expression by using the double angle formula. Right, so you substitute it here. And that's why your equation will become something like this. You're having 6 and then pi over 4 theta, pi over 4, 0. Then I will want to make it become cos 2 theta plus 1 divided by 2. Then again, every time before the integration, I prefer to take out all the constant first. I take out the 2, I'm having a 3 here. And after that, I start integration. Integrate cos 2 theta, I will get sine 2 theta. Then differentiate the 2 theta here, you get a 2, right? So divide it by a 2. Then integrate 1, you are having a theta, so you just put it as a theta here. Then pi over 4 and 0. And now you can start substituting the value inside. Sine 2 theta means sine 2 multiplied with pi over 4. So 2 over pi over 4 is pi over 2, right? So sine pi over 2, you get a 1. Sine pi over 2, you get a 1. Substitute pi over 4 into the theta, you're having pi over 4. Substitute 0 into the both term here, you'll get 0 plus 0. Okay, therefore, if you try to multiply in the answer, right, the constant 3 inside the bracket, so you'll be having 3 over 2 plus 3 over 4 pi. Alright, and this is the answer because in this question, they did hint us that our final answer should be in the form of a plus b pi. And then it is exact value, right? So if you try to observe our answer here, it is exactly the pattern that that they request, a plus b pi. And both of these are rational number. Okay, yeah, so this is basically how we solve the question 11, right? And this is the end of the video, yeah? So thank you very much for watching the video.